If you put two objects on the scale, leaves which weigh a pound and a block which weighs a pound, the question is, which one is heavier? Well, the answer is they have the same weight and the same mass, so they actually weigh the same amount, but there is something that is fundamentally different. The leaves take up more space, and the cube takes up a very small amount of space. And what is related to this is that they actually have different densities. And to define density, your density is equal to the mass of your object divided by the volume. And the volume is essentially how much space your object takes up. If we break down this equation a little bit more, we can have the case where we have two objects of the same volume, indicated by the same size cubes, but one weighs more than the other, the 5-gram one versus the 2 grams. So in terms of density, the 5-gram cube will have a higher density than the 2-gram cube, or we also know this as the 5-gram cube being more dense than the 2-gram cube. This is one way they can ask you the question. Compare two different objects with the same volume but different masses. Or we could have the same mass case, and that's what we had previously, where we had leaves that weigh a pound and this gold block that weighs a pound. And since they have the same mass, but one takes up way more space, by fundamental of this equation, if you put a bigger number in the denominator, you're going to actually have a less dense or less density for the pound of leaves versus the pound of metal. This is the first equation that I want to cover within my channel because this is a very fundamental equation that everybody will learn at some point in their science career. And with density, there's usually a fundamental rule with the same compound, but in different phases. We have our solid phase on the left, liquid in the middle, and our gas phase on the right. Usually 99% of the time, the solid will have a higher density than your liquid, which will have a higher density than your gas. This is very fundamental to a lot of compounds, but there's one specific compound known as water that actually does not obey these rules, and we can talk about that at a later video. Density was studied by Archimedes, and the way that he ended up studying this was the idea of learning about buoyant force of objects immersed in a liquid. On the left here, we have two different materials. We have a green material and this blue material. What we do know is that the green material has a density of 2 grams per milliliter, and our blue material has 1 gram per milliliter. Our liquid or our blue case has a density of 1 grams per milliliter. So the green object is more dense than our liquid. And so what actually ends up happening, and this is what you see in everyday life, is that when you put this green object in this liquid, it will sink to the bottom because it is more dense than your liquid. And this is fundamental. Putting anything in water, the more dense it is, if it's denser than water, it will sink to the bottom of your container. Let's take a look about how density can be used to identify different objects or used in different practice problems, especially in general chemistry. So let's say we have this object here and we weigh it and we have a mass of 0.625 grams. What else we need to know is actually the volume associated with this. And assuming this is a perfect cube with a length of one side of half a centimeter, we have everything we need to know in order to find the volume of this cube. So let's say this cube actually is potentially either gold or fool's gold. You found this cube on the ground and you want to identify if it's actually worth something or worth basically nothing. The one major identifier that you could do and do this test on your own is discover the density, where the density of gold is about 4 times the density of fool's gold. So we have the mass and we have the volume, where the volume is just going to be the volume of the cube, which is one of your lengths cubed. So you get a volume of 0.125 centimeters cubed, and our mass is 0.625. And so our density is going to be our mass divided by our volume, where our mass is going to be 0.625 grams divided by 0.125 centimeters cubed. We're going to end up getting a density of 5 grams per centimeter cubed. So unfortunately, this object is most likely fool's gold, unfortunately for us. So we were very unlucky. Now moving on to a different case, let's say our object was not very nicely shaped that we can find the volume so easily. Where we actually have this crystal and we're trying to determine if the crystal is either calcite or quartz. So we weigh this crystal and we have 13.25 grams, but the question is, how do we find the volume easily? We can measure all these geometric properties and of the 3D shape and try to calculate volume, or Archimedes actually came up with a very simple answer, and that's going to be referred to when you put a second object submersed in water. And the idea is, let's say you have a container of water without the object, and then you put the object in and you submerge it fully in that water. The volume that that water displaces should be around the volume of your specific object, and everything is completely submerged. Now we have an idea of a mass and a volume again that we can use to calculate the density between quartz and calcite to see if this crystal is quartz, which is what we probably want. And so the volume of the object is equal to the volume displaced, or the volume of water displaced, which is around 5 milliliters. And what we need to know is that a milliliter is actually equal to centimeter cubed. That is a definition, and it's a very important definition for unit conversions in terms of volume. And we know the mass is 13.25, so we can find our density by taking our mass dividing by our volume, and we get 13.25 divided by 5 centimeters cubed. We end up getting a density of 2.65 grams per centimeters cubed. So luckily for us, it is most likely quartz. Now there's many extra practice problems that I'll post in a later video, but this is a very brief introduction into density and how you might see it in a lab-like setting. Please check out my channel, The Science Equation. Please like this video and also subscribe to for more chemistry and math related content. Thank you and have a good day.